something that we perhaps take for granted. Look up into the sky on a clear night, and there are endless twinkling orbs. And in reality, they only ever represent just a tiny, tiny fraction of what's in the universe as a whole. Over the years, our knowledge of them has improved, and especially in recent times. So much so that we can't imagine what life would be like without our closest one, the Sun. And, spoiler alert, it isn't good. There are between 100 to 400 billion stars in our galaxy, the Milky Way. Stars are then classified into various types based on their spectral characteristics, temperature, and luminosity. A key factor in these features is mass, which also determines how long a star lives for and how it eventually dies. All stars begin the same way, though, as vast nebulae of dust and gas in space. The particles in these gas clouds are gravitationally attracted to one another, creating a domino effect of collisions. As everything clumps together, over time, a protostar emerges, and once its mass and temperature reach a critical threshold, nuclear fusion begins, marking the birth of a new star. At this point, the stars enter the main sequence phase, the most stable and prolonged period in their life cycle. And this is where our Sun currently resides. It's a reasonably average star at a reasonably common point in its timeline. During the main sequence, stars consume the majority of their hydrogen fuel. The dynamics within a star are dominated by two rival forces. The first is gravity, which works to pull the star inward into collapse. The second is the outward pressure produced by nuclear reactions within the core of the star. During the main sequence phase, these forces more or less balance each other out, which is what results in the stability we see. But still, nothing lasts forever, not even stars. And the total lifespan depends largely on mass. The larger the star, the faster it burns through its fuel, and the shorter its lifetime will be. In fact, the most massive stars live for only a few million years, an exceedingly short time compared to most others. On the other end of the spectrum, the smallest main sequence stars, red dwarfs, are thought to live for tens of billions to trillions of years. For perspective, our universe is just 13.8 billion years old, so many will live for longer than the universe has been here so far. Our Sun in particular is what's known as a G-type main sequence star, aka a yellow dwarf, and is expected to shine for around 10 billion years total. It's currently 4.6 billion years old. In reality then, it will one day stop burning, but that event won't be sudden, and it also won't be for a long time yet. Hydrogen is the primary fuel for all stars, including our Sun, which is burned up through nuclear fusion. In this process, atomic nuclei combine to form a new, heavier nucleus, specifically helium, which builds up in the star's core. As hydrogen is depleted, this core contracts and heats up, and hydrogen fusion in the star's outer shell accelerates, leading it to expand into a red giant. This is what will happen to our Sun. In other more massive stars, fusion also produces even heavier elements, such as iron. However, the fusion of iron actually consumes more energy than it produces. So massive stars amass an inert iron core deep in their center, which slowly grows over time, until eventually the effects of fusion are no longer able to counteract gravity. Once this happens, the massive star is doomed, collapsing inward. It's tricky science to envisage, but the result is something that we can all picture. One of the most violent explosions known in the universe, what we call a supernova. All that's left behind after a supernova is either a small and dense neutron star or a black hole, which will gradually absorb anything unfortunate enough to get too close. But again, in reality, our Sun isn't massive enough to go supernova. It will become a red giant instead. We have about 5 billion years until this happens. As it expands, the Sun will consume the entire inner solar system, most likely including the Earth. It will spend up to 1 billion years in this period, enduring a prolonged death. Eventually, our Sun will completely lose its outer layers and shrink into a white dwarf star, similar in size to that of our home planet. Those lost outer layers will then go on to form a planetary nebula, much like the material it was originally formed out of. Together with other material in the interstellar medium, the remains of our Sun may eventually birth a new star, continuing the cycle. So all of that is what will happen if the Sun stops burning due to natural causes. But what then if it just suddenly and mysteriously stopped burning, billions of years before its due date? If by stop burning we mean stops nuclear fusion reactions, then there would actually be very few noticeable effects on human timescales. We would cease to see neutrino emissions, which are natural products of nuclear fusion, but neutrinos rarely interact with anything they pass by. There are approximately 100 billion neutrinos from the sun passing through your thumbnail every second, so the loss of these would hardly be a significant change. In the very long run, though, life on Earth would have a major problem. The next few million years would see the sun contract, causing its temperature to increase. Ultimately, once the sun reached about 1/100th of its current size, the contraction would come to a standstill, and the sun would be considered a white dwarf. While it would be hotter than the sun is now, it would be significantly smaller. It would also cool over time. The so-called Goldilocks zone for habitable planets around it will have been distorted beyond recognition, and Earth would certainly no longer dwell within it. By the time any of that became an issue, though, you definitely wouldn't be around to care. So if the sun switching off is a fear on your list, then feel free to cross it off. But what about in another alternate scenario where all of the sun's heat just immediately vanishes, and it does turn off completely? Ignoring the impossibility of such a thing ever actually happening, this would really be quite terrifying. All plants, which convert sunlight into energy through photosynthesis, would die out. For most plants, this would take just a handful of weeks, but some trees might be able to last a few decades before succumbing. And once the plants go, animals will soon follow, on both short and long-term scales. Within a week, Earth's surface would reach average temperatures of below -5 degrees Fahrenheit. Then after a year, it could be as low as -94 degrees. By this point, the oceans will have completely frozen over, causing the deep seas beneath them to become the new warmest places on Earth due to the ice sheet's insulation. After a few million years, the temperature on Earth would bottom out at -400 degrees, only 60 degrees higher than absolute zero. The only places hospitable enough for humans to live would be in submarines at the very deepest depths of the ocean, or in areas of high volcanic activity where we could utilize geothermal energy to keep warm. If this were possible, humans could live off volcanic energy for thousands of years. But of course, between now and then, our species will have endured an untold amount of suffering and hardship. Ultimately, it's extremely unlikely that we, or perhaps anything else, would survive. This is an incredibly bleak scenario, and life on a post-sun Earth would not last long at all. Fortunately for us, the laws of physics say that it's also a complete impossibility. So we can all rest assured that that orange, glowing, life-enabling orb in the sky will keep rising for the remainder of our lifetimes, and then a few billion years on top of that. But otherwise, that's what would happen if the sun suddenly stopped burning.